So here in this problem, we need to resolve the given rational fraction into partial fraction. So let's begin. First, we'll have to check whether if it is a proper rational fraction or not. Because if we take our original fraction, which is x plus 1 times x plus 2 multiplied to x plus 3 whole divided by x plus 4 times x plus 5 times x plus 6. Now what we're going to do for the time being, we're going to multiply the three factors in the numerator as well as in the denominator, and this is going to give us x cubed plus 6x squared plus 11x plus 6, and in the denominator we're going to have x cubed plus 15x squared plus 74x plus 120. Now clearly we see that the degree of the numerator is exactly equals to the degree of the denominator. All we have to check for is the highest power of x, so that's 3 in both the numerator and the denominator. So this is not a proper rational fraction. To convert it into a proper rational fraction, that means we need to have the degree of the numerator less than the degree of the denominator. Here we will have to perform a long division. Long division means we'll have to divide the numerator with the denominator. Let's perform the long division. So our numerator, which is x cubed plus 6x squared plus 11x plus 6. So we're going to divide it by the denominator, which is x cubed plus 15x squared plus 74x plus 120. So we'll take this divisor and multiply it with 1, which is going to give us x cubed plus 15x squared plus 74x plus 120. So let's subtract them. So we have x cubed minus x cubed, that's 0. 6x squared minus 15x squared will be negative 9x squared. Then we have 11x minus 74x, so that's negative 63x. And then we have 6 minus 120, so that's negative 114. So this is our remainder. The reason why we divided it, because now we can rewrite our given rational fraction as the quotient, which is 1, added to the remainder, that's negative 9x squared minus 63x minus 114 whole divided by the denominator x plus 4 times x plus 5 times x plus 6. So what we have to do, we don't have to worry about the first term, that's 1. All we have to worry about is the second term only, because here clearly this is a proper rational fraction. The degree of the numerator is now lesser than the degree of the denominator. So let's try to convert the given rational fraction, which is the second term, into partial fractions. So we're going to suppose let negative 9x squared minus 63x minus 114 whole divided by x plus 4 times x plus 5 times x plus 6. Since we have 3 factors in the denominator, so we'll get 3 partial fractions. The first partial fraction, let it be denoted by a over x plus 4. Then the second partial fraction will be denoted by b over x plus 5. And the third partial fraction will be denoted by c over x plus 6. We're going to label this as number 1. Let's label this as number 2, and the original equation is number 1. Now, to find out the value of a, b and c, we'll multiply throughout with the denominator, which is x plus 4, x plus 5 times x plus 6. That's going to give us negative 9x squared minus 63x minus 114. This will be equals to, we have x plus 5 multiplied to x plus 6 times a, plus we have x plus 4 multiplied to x plus 6 times b, and the third term will be x plus 4 multiplied to x plus 5 times c. Now we need to find out the value of a, b and c. To find out the value of a, b and c, we're going to choose 3 specific values of x. So let's try to understand how to choose the value of x. To find out the value of a, here we see that a is present at the first term. We will make the second term and the third term go to 0. To do that, all we have to do is look for a factor that's common to both the second term and the third term. So here we see it's x plus 4. So that's common to both of them. So if we equate x plus 4 to 0, or simply say x equals to negative 4 and substitute this into equation, then our second term and the third term vanishes and we are only left with the first term, and that will help us obtain the value of a. So let's do that. So we have -9 multiplied to -4 squared minus 63 times -4 minus 114. So this will be equals to, we'll plug in x equals -4 into the first term. So -4 plus 5, so that's +1, multiplied to -4 plus 6, so that's +2 times a. On the right hand side we have -6, and on the left hand side we have 2a. So a value, that's going to be equals to -3. Next we are going to choose x in such a fashion, the value of x in such a way such that the first term and the third term goes to 0. Now we're going to look for a factor that's common to both the first term and the third term. So here we see that it's x plus 5. So we're going to take x equals to -5. That means our equation will now become -9 multiplied to -5 squared minus 63 times -5 minus 114. So that will be equals to, so the first term and the third term goes to 0. Don't have to worry about it. We have -5 plus +4, so that's -1, multiplied to -5 plus 6, so that's +1 times b. So this is going to give us -24 equals to -b. So v value comes out to be +24. And finally, to find out the value of c, all we have to do is choose x in such a fashion such that the second and the first term goes to 0. Here we can see that if we take x plus 6 and equate it to 0, that means x equals to -6 will make the first term and the second term disappear. Now we're going to get -9 times -6 squared minus 63 times -6 minus 114. So that's equals to the third term, which is -6 plus 4 gives us -2. -6 plus 5 gives us -1, all multiplied to c. Solving this, we get the final value of c, which is equals to -30. So we have obtained the value of a, b, and c. Now we can substitute this into equation number 2. So let's do that. In place of a, we have -3, all divided by x plus 4. Then in place of b, we have +24 divided by x plus 5. And in place of c, we have -30 divided by x plus 6. Right. So we have obtained equation number 2, and our original equation will then become, if this will be equals to, so we had the quotient that was 1, so we have 1 minus 3 over x plus 4 plus 24 over x plus 5 minus 30 over x plus 6. So we have successfully resolved our given rational fraction into its constituent partial fractions.